Application of differentiation, applied maximum and minimum. And this is my teammate, Nur Dayana Izzati binti Suhaimi, Nur Fatini binti Muhammad Rizwan, Nur Fadilah binti Razak, Nur Syara Afifah binti Muhammad Fauzi, and Nur Omara Najwa binti Muhammad Hafni Wardi. What is application of differentiation? Differentiation is a process of mathematics through which and find the rate for the different function with respect to their corresponding variable. It may be said that a function is differentiated to determine how it changes with a change in input. The result of differentiation is called by derivative of the function. Imagine a curve on the graph that represents some relationship like distance over time. Differentiation helps us figure out the slope of the curve at any given point, and the slope tells us how fast or slow the function is changing at the specific point.
Next is problem introduction. Why is it used? Because it provides powerful tools for understanding and solving problems. We encounter situations where we need to optimize a certain quantity. Next is such problems involve finding the maximum or minimum value of a function under specific constraints, and this can be effectively solved using the principles of differentiation. For example, businesses aim to maximize their profit and engineers design structure to minimize material costs.
Question A. Show that the surface area of the container is 2 pi r power of 2 plus 1200 over r. Firstly, we need to know the formula for the closed cylinder. Second, use the volume formula to eliminate H. Given volume of cylinder 600, pi r power of 2 H equal to 600, H equal to 600 over pi r power of 2. Then substitute H into the surface area formula. A equal to 2 pi r power of 2 plus 2 pi r H. 2 pi r power of 2 plus 2 pi r in bracket 600 over pi r power of 2. Lastly, we need to simplify this. So, the answer of the question A is 2 pi r power of 2 plus 1200 over r.
So next, we move to the next question, that is, find the values of R and H that minimize the total surface area of container, and then give the answer to two decimal places. And then, first thing first, we must find the derivative, which is, in the question, the area given is by 2 pi r squared plus 1200 r to the power of -1. And then, we express it in the first derivative, and it becomes dA over dr equal to 4 pi r minus 1200 r to the power of -2. And then we bring the r to the power -2, we bring down the expression into a fraction, which is, it becomes 4 pi r minus 1200 over r squared. So for step 2, we let the derivative equal to 0. So it will be 4 pi r minus 1200 over r squared equal to 0. And then we move the negative 1200 over r squared to the right, where it will be 4 pi r equal to 1200 over r squared. And then to remove the fraction, we bring the r squared to the left, where it will be 4 pi r cubed equal to 1200. And then to find the single r from the r cubed, we bring the 4 pi to the fraction in the right, where it will be r cubed equal to 1200 over 4 pi. And then for the last part, to find the single r, we must cube root the 1200 over 4 pi, and the answer will be 4.57 centimeter. So next, we move to the step 3 where we find the second derivative. So for the second derivative test, we write again the equation that is d square a over dr equal to 4 pi plus 2400 r to the power of negative 3. And then we change the 2400 r to the power of negative 3 into a fraction, so that the 4 pi plus 2400 over r cubed. Next, when r equal to 4.57, we substitute again in the expression, which is 4 pi plus 2400 over r cubed. Then we substitute with 4.57, and then the answer will be 37.71, that is over 0. So, when r equal to 4.57, we can conclude it is a minimum value. So, next, when r equal to 4.57, we can substitute it into the expression to find h, which is h equal to 600 over pi r squared. So, we substitute the radius, and then it will be 9.14 centimeter. And then for the last question, find the minimum surface area of container. So to find the A minimum, we substitute all the answer we get into the equation of the surface area, which is A minimum equal to 2 pi r squared plus 1200 over r. And then we substitute the radius that we get in the equation. So 2 pi, substitute 4.57 squared plus 1200 over 4.57, and then the answer would be 393.81 centimeters squared.
Conclusion. Differentiation is a fundamental concept in a calculus that involves determining the rate at which a quantity changes. It provides a method for finding the slope of a curve, the instantaneous rate of change, or derivative of a function. This process is widely applied in various fields such as physics, engineering, economics, and biology to solve real-world problems involving optimization, motion, growth, and change. By understanding and applying differentiation, one can analyze and predict dynamic systems, optimize outcome, and gain deeper insight into mathematical relationships. In summary, differentiation connects math to practical application, which make it easy and essential for solving a problem.